Lesson 6.3 is solving linear systems by using the method called adding or subtracting. Sometimes this is called the elimination method, and that's usually what I call it because it's less to say. This is the third method we have in solving systems. If you recall, the first method was graphing, the second method was substitution, and now we have elimination. Elimination, just like substitution, takes 3 steps. Our first step is to add or subtract the equations to eliminate one of the variables. So really we're building a third equation, and in doing so we're eliminating either the x or the y variable. Second step, you're going to solve that new equation for the variable that you did not eliminate. And the final step, once you have that answer, you're going to substitute it into either original equation to find the value of the variable that you did eliminate. So here we go. This problem right here I just have to show you that the first thing you have to do if they're not lined up in order is you have to make sure that the like terms are arranged in columns. So they need to be stacked. Usually it's just easiest if we put them in standard form. So remember, standard form gets the x's and y's on one side and the constant term on the other. So I'm noticing here that my x's are on opposite sides of the equal sign. The 9x is on the left and the negative 11x is on the right. So what I'm going to do is I'm just going to leave my first equation because it does appear to be in standard form. And my second equation, to move the negative 11x over, I'll add it. And the y is already on the correct side, and so is the 8. So here they're lined up, the x's are lined up, the y's are lined up, and the constants are lined up. And then we could go ahead and eliminate. We're not going to finish this problem. It was just put up here to show you how you would stack them. This problem right here, though, they are in correct form. And what I want to do is I want to look at the variable terms. 6x, negative 2x. Well, if I add them, it gives me a 4x. If I subtract them, it's going to end up giving me an 8x because I would make this a positive. So that's not going to eliminate. But the y's, I have a y and a y. Y minus y is no more y. I have 0y. So I'm going to subtract. When you subtract, I want you to get in the habit of doing this. You put your subtraction sign, but then you go opposite, 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 and you're going to turn around and add anyways. So even though it is subtraction, we change everything in the bottom equation to the opposite and then turn around and add. So 6x plus 2x is 8x. Y plus negative y is eliminated. We don't write down 0y. And 39 plus 17 is 56. Divide by 8 and now x equals 7. There's step 2. Step 3, I'm going to go ahead and plug this x into either of these equations. I generally go to the top. It's just a habit of mine. So I have 6 times 7 plus y equals 39. 6 times 7 is 42. And when I subtract 42, I get a negative 3. So my solution is 7, negative 3. And it's just that simple. Let's do another one. Here they are stacked. Notice that my x's are not exactly alike or exactly opposite, so I'm going to move on. My y terms now are exact opposites. If they're exact opposites, you go ahead and add. So here I get a negative 2/3 x plus 1x is going to give me a positive 1/3 x. The y's drop out. 38 plus negative 33 is 5. I can multiply now by 3, and x equals 15. I will go ahead and put this right in the top. You may choose to put it in the bottom if you don't want to deal with the fractions, but I'm going to put it in the top because I want you to get good at dealing with fractions. So negative 2/3 times 15 plus 6y equals 38. 3 divides into 15 5 times. Negative 2 times 5 is negative 10. Plus 6y equals 38. Add the 10, so 6y equals 48. Divide by 6, and y equals 8. So my answer is 15, 8. And again, ultimately, remember what this means is if I were to graph these two out, these two lines, they would intersect at the point 15, 8. Let's try this one. Again, I chose problems with fractions because I don't want you to shy away from them. Oops. So here, these are not exactly alike or exact opposite, so I'll skip it. These terms are exact like terms, so when you have exact like terms, you subtract. So maybe you want to write that down. Exact like terms, you subtract. And put up here exact opposite terms, you add. Okay, so I'm going to subtract. So remember, I'm subtracting, so I go opposite, 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 add. So 7x plus negative 2x is 5x. My y's are eliminated. Negative 29 plus 9 is negative 20. Divide by 5 and x equals negative 4. So I'll go ahead and substitute that in. 7 times negative 4 minus a third y equals negative 29. So negative 28 minus a third y equals negative 29. Add 28, negative third y equals negative 1. Multiply by negative 3 to eliminate, and y equals 3. So my answer is negative 4, 3. Okay, fishing barge. A fishing barge leaves from a dock and it moves upstream against the current. So you're fighting the current, so you're going to have a little more power when you're rowing, or I guess if the barge just goes. And it's going at a rate of 3 8/10 miles per hour until it reaches its destination. After the people on the barge are done fishing, it goes downstream the same distance, but now it's going with the current, so it's pushing it along, and now it's going at a rate of 8 miles per hour until it returns to the dock. The speed of the current remains constant, so going upstream and downstream, the water's moving at the same rate. They want us to use the models here to write the equations and then figure out the speed of the barge in still water without the current, and then the speed of the current. So upstream it says the speed of the barge in still water, we're going to call that x. And then speed of the current we'll call y. So x minus y equals the speed of the barge. Well, upstream it's going 3 8/10 miles an hour. And then downstream it's going to be x plus y because the current's pushing the barge along, and now it's going 8 miles per hour. So here's our system. And in this particular case, we've got two choices. We have exact same x terms, but exact opposite y terms. I generally choose for, if I can, I look for exact opposites because it's less work. Remember, if you have exact opposites, here, opposites, I guess it's a good thing that I went back, exact opposite, make sure you put that in, opposite terms you add. So exact opposites, I'm going to go ahead and add. X plus x is 2x, the y's eliminate, 3 8/10 plus 8 is 11 8/10, divide by 2, and x equals 5 9/10 miles per hour. So this is the speed of, it says we're looking for the speed of the barge in still water. So this is in still water. Now I'll go ahead and put that back in. I'll just put it in the top equation. So 5.9 minus y equals 3.8. If I subtract, I have negative y equals negative 2.1. So positive y is positive 2.1 miles per hour, and this is the speed of the current. Okay, one more. A rental company charges a flat fee of X dollars for a floor sander plus Y dollars per hour of the rental. One customer rents a floor sander for 4 hours and they pay $63, and then another one rents a floor sander for 6 hours, and their total is $87. So they want us to figure out the flat fee and the cost per hour. So part A, the flat fee we'll just call X, and it's Y dollars per hour. And the first person does it 4 hours, and then they pay $63. The second person pays the same flat fee. They rent it for 6 hours and pay a total of $87. Here's my system. I have exact like terms, so remember you're going to subtract. So the x's are eliminated. 4y plus negative 6y is negative 2y. 63 plus negative 87 is negative 24. So y equals 12. So it's $12 per hour. And then now we need to figure out what it is for the flat fee. So x plus 4 times 12 equals 63. X plus 48 equals 63. And x is $15 for the flat fee. And finally, part B. How much would it cost someone to rent a sander for 11 hours? Well, it's $15 for the flat fee plus $12 times 11 hours. So it's 15 plus 132, I believe. Yep. So $147. All right, so there is the elimination method, and here's your assignment if you want to get started on it. It's lesson 6-3, page 389 to 391, 4 to 32 even, 35, and 39 to 42.